Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the homework. First problem 77, the surface area and volume of the prism shown at the right. Find what those are. Okay, so remember, the surface area is if we took every single face of a prism and we counted the number of square units that covered each one of those faces, then we would add all of those areas together for the surface area. So to find the surface area, we have to consider how many square units are in the front, how many are in the back, how many on the top, how many square units on the bottom, and then you've got a right side and a left side. So let's start with the front. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From if you were standing right here, looking in that direction, you would see 10 square units. And what are we calling these? Just square units? Yeah, square units. And the back should be the same. You picture this back tier here. You've got 2 rows of cubes. There's 5 cubes each, so that means that there'd be 10 square units that you wouldn't be able to see on the back as well. With these prisms, we often find where the front and the back match, the top and the bottom match, and the right and the left sides match. It's not always going to work out perfectly that way, but we'll see about this one. So let's look at the top. If we're going from an upper view down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the bottom would be kind of like the back, right? So you got two rows there, and each one of those rows has 5 square units. So that would be a total of 10 there. And then on the right side, you got your 1, 2, 3. And on the left side, there must also be 3, because while you can't see this one, well, you can't see any of them, but you know there's one right there. You know there's one here in the front, and there's another one in the back that you can't see. So there would be 3. So that's a total of 40 plus 6 is 46 square units. Volume, a little bit easier to figure out. With the volume, it's just picture where all the cubes are. You can see a bunch of the cubes, but you can't see all of them. But you know that this one must be resting on top of another one that's underneath it. So you got 1, 2, 3, 4, 5 in the front row, and then you've got 5 here and another 5 there for a total of 10. So that makes a total of 15 cubic units, filling up this entire figure right there that you see at the right. Find the area of each circle below. Okay, so the area formulas, pi r squared. And in this case, we know what the radius is, so we're just going to take pi and multiply it times whatever 8 squared is, and that ends up being 64. So 64 times pi is 200.96. Now that's the pi where you round it off to 3.14. If you had taken 64 and then, oh, that's not the right calculator. Let me get the right calculator that has the pi button. Okay, so 64 times pi. This is a little bit more accurate. Both of them round to 201. This is just slightly more than 201. This is almost at 201. So, you know, we're going to be rounding either way. Even this is somewhat rounded off and not perfect as far as pi goes. But about 201 should be the right answer. Here we are given the diameter, which we have to cut that in half to get our radius. So we're going to take 30 squared, which is 900, and 900 times pi. The bigger your radius, the more of a difference you're going to see depending on which pi you choose to use. For instance, if I do pi times 900, this pi, I'm going to get 2,827.43. How does that compare to this one? Well, it's about 1 more square centimeter. If I just use the 3.14, which is a little bit less than pi, times 900, times 900, that's when you get this answer here. So either one of those answers is okay. Somewhere in the 2,826.27 range is the area of a circle with a diameter of 60 centimeters. All right, so Glenda made a scale model of the Empire State Building of New York. The building itself is 1,250 feet high. Her scale model is 5 feet high. So what ratio that compares the heights of, what is the ratio that compares the heights of the two? So I guess it's a 5 to 1,250, right? So this is the model, that's the real, and I just simplified it down to 1 over 250. So this would be for every 1 foot of her scale model, that would represent 250 feet in real life of the actual building. So if the doorway of Glenda's model is 2 inches wide, how wide would you expect the doorway of the real building to be? And so we set this as a ratio, right? 1 over 250 is equal to 2. Oh, I think I might have made a mistake here. Hold on for a second. Let me pause and reflect on this. I might have to make some changes. All right. I'm happy to say I did not make a mistake. It seemed odd because this is feet, right? 1 foot in her scale model corresponds to 250 feet in real life. And this was in inches, not in feet. But it turns out it works out just the same because when you're doing proportional reasoning, you don't have to worry about the units of measurement, although you do want the ones in the top and the bottom matching. So I changed this 1 foot for every 250 feet to be 12 inches, since there's 12 inches in a foot. And that would result in us, if we did cross multiplication, we would get 12x is equal to 500, and then we divide each side by 12, you get 41.6. Well, that's what I'd written here. So if we just disregarded whether these were feet or inches, you double this to make 500 inches. Well, that's what we did right there when we multiplied 250 times 2. But then to convert that to a number of feet, we have to do the conversion, which involves you dividing by the number of inches in a foot. And so that's what happened here. So if you said 500 inches, that's correct. If you said 41.6 repeated feet, that's okay. But I just converted this repeating decimal. 2/3 of a foot is 8 inches, so 41 feet 8 inches. Now that's the doorway, which I believe is not a single door. What it probably is there's a series of doors that people can walk in, because it's such a big building. In the morning when everyone's coming to work, you don't want everybody having to file through one single door. So it's probably a series of doors, which spanning from left to right is a little over 40 total feet. So if the real building contains 102 floors, how many floors should the model contain? Well, if it's a scale model, it should have 102 floors, because we want it to be an exact replica, right? So it would be similar to the original one. So good luck with that. That sounds like a fun model to make. All right, simplify each of the following expressions. And we just have to remember that we follow the order of operations. Go ahead and pause the video so that I don't go too quickly and you can check all of your answers. I'm not sure where to even begin, to be honest with you. I'll do a couple of them. And then once again, as in the past, if there was one that you didn't understand how to do and you wanted to send me an email, I'd be happy to work it out for you and send you the response. First off, exponents take place before adding. So this becomes 64 plus 49 is 113. Here you have to deal with fractions. So when you square 1/2, 1/2 times 1/2 is 1/4. And 2/3 times 2/3 is 4 over 9. Now you're going to have to get a common denominator, which would be 36. So 9 over 36 plus 16 over 36. Remember our coat of arms, the idea of doing the cross multiplication. Basically, 1/4 times 9 over 9 is 9 over 36, and 4 9s times 4 over 4 gives you your 36 denominator as well. So that's how you get your 25 over 36. Here we have this rule that says that the exponent applies to whatever it touches. So you technically have to do everything inside the parentheses before you raise this to the second power. 2 is being raised to the second power, so that becomes 4 plus 6, which then becomes 10. And now you can square it because we've taken care of all parentheses, and that's how you're going to get 100. Okay, so once again, if you need any help on any of these, send me an email. I'll work out some of the others if you need it. The Wild West Frontier Park now offers unlimited day passes for $29. You can go on as many rides as you want. The original plan charged $8.75 just to enter, and then you had to pay to go on each ride, which was $2.25. Write an equation to determine the number of rides that would make the total cost equal for the two plans. All right, we are going to get into this in 8th grade. This is called a system of equations. And basically what we know is this. The total cost, which is y, under the new plan is $29. However, the total cost in the previous plan was to take $2.25 for every ride you go on, where X represents the number of rides, plus the entry fee to get into the park. So if the total cost is going to be the same, because that's what they're saying, write an equation to determine the number of rides that would cost equal for the two plans. So we got to figure out what value of X makes this quantity here equal to this quantity. So this is called the equal values method, where if y equals this and y equals that, then this must be equal to that. So we set up the equation and then solve for X by subtracting $8.75 from each side. And what do you get when you do that? That ends up being $20.25. So if $2.25 times X is equal to $20.25, then when you take this divided by that, I bet you're going to get 9 for your answer. $20.25 divided by 9, divided by 2.25, that's it. So how do you prove that that's correct? Well, plug in the number 9 here. What is 9 times $2.25? It's $20.25. Add that to the admission fee for the park, you get $29. That's the answer. So we can declare that if you go on 9 rides, then it's going to cost the same. So basically, this isn't actually, it's a really good exercise for you if you've got an option. Like when you go down to Santa Cruz Boardwalk, you can walk on the boardwalk, you could just hang out with your friends. You can go and buy an individual ticket if you feel like going on a ride, but you really just want to hang out with your friends. Whereas some people are like, I'm going on rides all day long. When do you make the decision to buy the all-day pass and the bracelet that allows you to go on all the rides as many times as you want? There was one year, I won't bore you too much with my stories, but there was one year when my daughters were really, really young, and we thought they all were going to want to go on these rides. And we bought everybody bracelets, Ben, the girls, and then mom and dad, me. Well, after they went on the first ride, they didn't want to go on rides anymore. So we blew like $30 on each one of them. They didn't want to go on any more rides. So good mathematical thinking. At what point does it cost the same? If you plan on going on more than 9 rides, it would actually be better to pay the $29 fee. If you plan on only going on a few rides, you're better off paying this amount. Now, I don't know if they're going to offer both plans in this situation, doesn't really make any difference, but that's a real life situation where you'd have to do this kind of math. All right, and then our last problem. Do girls read more than boys during the summer? Serena's class asked 30 parents to estimate how many pages their child read over the summer. They collected the following data. Now, just looking at these raw numbers, it's kind of hard to tell who reads more. I mean, I look through there and I see a 0 there, but I see some 200, I see some in the 200s here. So just looking at raw data is really hard to tell. This is where creating box plots and parallel box plots specifically can help us draw our conclusions. So you take each one of these sets of data, put them in order from least to greatest. Then you find the minimums and the maximums. Here they are. Then you find the medians. What number is in the middle? There's the median of that data. Here's the median of this data. Plug those in. It looks like just by looking at the median, which is another way of saying average, one could argue that the boys had the higher average number of pages, so they read more than the girls, just based on the averages, just based on the medians. But, you know, that doesn't always tell the full story, so you find your quartiles. Which number is in the middle here? Is at the 50 here. and the 40 there, and which numbers in the middle up here? Is that the 230 and the 210? Those are your quartiles. So when you reference both of these on a number line, you know, the maximums are the same, the minimums are close to the same. While the boys have the higher median, if you look at the interquartile range, the girls is a little bit farther to the right than the boys. So there's just, you know, I don't think you can definitively say who reads more. So that's my answer. Do the girls read more? You can't really tell. If you just go by the median, then it would appear that the boys read more. And if you go by the interquartile range, that box in the middle, it looks like the girls is farther to the right. So that sort of suggests that maybe they read a little bit more. But there's so much overlap here with the interquartile ranges that essentially the data reads the same. I'm going to say neither boy nor girl read more. It's pretty much even. All right, so that does it for this homework. So that we can get all of our lessons in time to do our chapter test by Friday, I have a lesson for you. The last lesson of the year is going to be today. That's going to be lesson 9.2.4. So why don't you go ahead and move on to that lesson, and then you'll have tonight's homework. Then we'll have study guides, and then we'll get into the chapter test on Friday. All right. Good luck with whatever. See you later. Bye.
Hey, feeling good, like I should.